Hello everybody, welcome back to my channel. If I sound off, it's because I'm sick. But we're just gonna push on through. So, science. It's important. DNA helps you know where you came from or your ancestors and can solve crimes. Chromosomes help determine if a fetus becomes a boy or a girl. But do you know the true science behind it, and more importantly, who discovered it? Well, the science is science, and a woman discovered it. Nettie Stevens. Let's get started. Ugh. I'm fine. Nettie Maria Stevens was born on July 7th, 1861 in Cavendish, Vermont. She grew up in a middle-class family with her parents Julia and Ephraim Stevens for the first several years of her life. Tragedy came to Nettie early. When her mother passed away in 1863, her father remarried and moved the family to Westford, Massachusetts. At this time, the country was still recovering from the Civil War, and women still had very little opportunities in education and professional careers. Women were still expected to do the traditional roles. However, things were beginning to change. In an odd way, it was thanks to the Civil War and the mass amount of men tragically, unfortunately, completely could be avoidably killed. The workforce needed workers, and women were the next best option. Women started gaining independence, began working in a wider range of jobs like journalism, education, factories, and activism. But there is still pushback from the government, social norms, men. That was not a pun. I coughed and men came out. Anyway, luckily for Nettie, her father worked as a carpenter and was earning enough money to send Nettie and her sister Emma to not only a good school, but to pay for them through high school. They attended the trailblazing Westford Academy, a private school founded in 1792, and was for children of any age, nation, age, or sex, as long as they could read the Bible and pay the crazy amount of 9 shillings or about $62 today. Both boys and girls could attend the school. In school, Nettie was near the top of her class, and when she and her sister graduated in 1880 when she was 19, the sisters were just 2 of 3 women in their entire graduating class. After graduating, Nettie moved to Lebanon, New Hampshire, where she became a teacher, teaching high school English, Latin, math, physiology, and zoology. She enjoyed her time there, but she wanted to gain more education. So, after 3 years of teaching and saving, she moved back to Vermont around 1883 to attend Westfield Normal School, now just Westfield State University, a teacher's college. At the college, Nettie was dedicated to her work and was liked by both her peers and teachers. She completed a 4-year course in just 2 years and graduated with the highest scores in her class. In today's age, she would have easily been valedictorian of her class. This pattern of work, save, educate, repeat went on for a few years until 1896. She had saved enough money to move to California and attend Stanford University. Now you need to understand how massive this is. 1, at this point, Stanford was a co-educational college. How it became basically an all-boys school began in 1899. Editor Jada here. For some reason, my camera freezed at this point. So basically what had happened was in 1899, when Jane Stanford feared that the college, which was established in memory of her son who died at just 15 of typhoid fever, was becoming a women's college, and that didn't align with her vision for the academic year of 1898 to 1899. Women's enrollment was 463, and overall enrollment at that time was 555. So there was a heck of a lot more women at Stanford in that year that 500 cap enrollment was placed. And apparently Jane wasn't a fan of more women getting education than men for reasons that I don't really quite understand, but we're just gonna roll with it. So that's why she put that enrollment cap on. And by the time 1933 came around, the ratio of men to women was 3 to 1. Now back to my face. So Nettie is at Stanford before this idiotic cap was implemented, and 2, Stanford was only 5 years old. It was opened on October 1st, 1891. Nettie enrolled in 1896. At Stanford, Nettie became increasingly interested in history and cytology, the study of structure and function of plant and animal cells, while she was working for the summer at Hopkins Marine Station, a marine laboratory at Stanford. Nettie was 35 when she attended Stanford, and just 3 years later, she earned her BA in 1899. A year later, she earned her MA, Master of Arts, in biology in 1900. After she graduated, she published her first manuscript on the history of ciliates, a group of single-celled organisms that play an important role in aquatic environments by eating bacteria and protozoans, basically parasites. Her report was detailed in the observations across the life cycle of the organisms and identified 2 new species. Just so you know, there are about 7,000 species of ciliates, but there could be as many as 40,000 species all over the world. But she discovered 2 new ones. And that's all that matters. After graduating from Stanford and kind of finding her niche, she then enrolled at Bryn Mawr College in Bryn Mawr, Pennsylvania, to study cytology, genetics, and embryology, the study of the formation and development of embryos and fetuses, and morphology, the study of form in living organisms, wanting to earn a PhD. She focused on regeneration in the early development of multicellular organisms, the structure of single-celled organisms, cell division in sea urchins and worms, germ cells of insects, and the development of sperm and eggs. She was so brilliant at her work in all the areas that she was awarded a fellowship to do research overseas. Remember, America is in its Civil War era. Women are still considered property and not smart enough to do the man's job of counting. And this girl is being recognized for her brilliant mind, plus being awarded for it, plus going overseas to further her education? Unheard of. Nettie was named a President's European Fellow, yes, and spent a year in Naples, Italy, jealous, from 1901 to 1902, where for the first half, she studied and worked with marine organisms at the zoological station. Then she went to the University of Würzburg in Germany to study at the Zoological Institute. During her time at Bryn Mawr, she was described as an exceptionally bright, curious student and had an enthusiasm for science. While at the college in Germany, she worked with Theodor Boveri, a German zoologist, and became known for the first hypothesis in the cellular process that caused cancer. During Nettie's time there, Theodor was doing experiments that linked genetics to the odd dark markings under a microscope in cell nuclei that were known as chromosomes. Stay with me. What his work did was reveal that a set of chromosomes was needed for the development of anything to happen normally, showing that each chromosome had its own distinct identity, and this intrigued the heck out of Nettie. When Nettie returned to the States, she earned her PhD in biology. By this point, Nettie was pretty well respected, but was running out of savings. Not wanting to stop her dreams of researching, she was encouraged to apply for a research assistantship at the Carnegie Institute for Science in Washington, D.C. in 1904, but this fellowship required support. Luckily, her PhD advisor, Thomas Morgan, and head of the biology department of Bryn Mawr, Edmund Wilson, wrote very enthusiastic references for her. She would be awarded this fellowship, and she used part of the money for Nettie's and Edmund's collaborating research on sex determination. Okay. Time to talk science. Meet Austrian mathematician, meteorologist, and biologist Gregor Mendel. He discovered what was coined Mendel's law of heredity that later formed the foundation of modern genetics. These laws claimed how traits are passed from parents to children. These include the laws of segregation, where each parent contributes one specific variant of a gene to the child, the law of independent assortment, meaning the different traits are independent and don't influence the other, and the law of dominance, meaning the dominant, more prominent trait will be more visible in the child. Take skin, eye, hair color, personality, mental traits. We all know that chromosomes are passed through generations of specialized cells known as germ cells. You may know it as sperm or egg cells. Not shells, cells. Cells, egg cells. Sperm or egg cells. Give me a break. What makes the germ cells special is that they carry one copy of each chromosome, meaning that when a sperm fertilizes an egg, there will be a normal number of chromosomes. A normal human cell has 46 chromosomes split into 23 pairs, one from each parent. At the time Nettie began her research, it was well known that sperm was needed to fertilize an egg. But what we didn't know was what role the chromosomes within the sperm played in determining sex. Get ready to giggle a little bit, because I did. Some believed that the mother's diet and environment determined the sex. Mind you, that's still not far off from what we think of today, but no. I saw this thing where like if you drink a lot of milk, you'll have a boy. Or like if you eat strawberries mixed with like orange juice, you'll have a girl. Trying to force or manipulate the sex of a baby is crazy. The theories are nuts. But luckily, these theories began to weaken by the 1800s. Others believed it was only external factors. Some thought the sex was already determined at the point of fertilization and that external factors had nothing to do with it. Nettie wanted to learn exactly what chromosomes did in sex determination. When now Dr. Nettie Stevens began her research, she used unusual subjects: beetles, specifically mealworm beetles, and aphids, little sap-sucking insects. These insects were ideal for this research for many reasons, but the mealworm was particularly ideal because it inherited half of its chromosomes from the parent sperm and the other half from the egg, just like humans. By examining the sperm from the mealworm, Nettie saw that some sperm carried 19 large and 1 small chromosome, while other sperm carried 20 large chromosomes and no small chromosomes. Additionally, she observed that the sperm with the 1 small chromosome always made male offspring. Basically, Nettie found that a pair of chromosomes, 1 large and 1 small, could determine if the beetle worm was male or female. She called the large chromosome X and the small chromosome Y. She concluded that chromosomes, specifically on the father's side, are responsible for sex determination, and the mother has nothing to do with it. In very basic terms, it was King Henry VIII's problem that he couldn't produce male heirs, not the 6 wives, 2 of them he killed beheaded level, fault that they couldn't make male heirs because biologically his sperm was full of female making baby chromosomes and those biological traits were dominant. It also means that all embryos begin as female, because all eggs carry an X and females are XX chromosomes. Those 23 pairs of chromosomes, 22 are the exact same in every single embryo. The 23rd determines sex. The sperm has an X, the baby will be female, a Y, the baby will be male. It's not the woman's fault if she has a boy or a girl and the man wants a boy, because all men want boys for some reason. It's not the mother's fault. It just happens because of you, boy. Sorry. Rage. From her constant observing of the chromosomes, Nettie gave the final real evidence that an organism's sex is determined at the moment of fertilization based on the chromosomes rather than the environment or diet of the mother. Both Nettie and Edmund did this research at the same time, and both published their findings at the same time. They just worked and did separate experiments in their own ways. But, as is the usual case, many credit Edmund for discovering chromosomes. What made Nettie's discovery and publication more prominent than Edmund's was Nettie did the same kind of survey across 9 species of flies and 50 species of beetles, and she found that every single species had the same pattern of the XY chromosome phenomena. Basically what that means, she did a more extensive research of it just to make double, triple, quadruple, conflictable sure that what she was seeing was what she was seeing. Meanwhile, Edmund kind of did 1 or 2. Because sometimes what you see on the first time is not what you see on the second time. For some reason, Thomas Morgan had beef with the both of them, but mainly Nettie, and flat out refused to accept the concept of chromosome inheritance at the time. He is often credited with discovering the genetic basis for sex discrimination because he didn't like that Nettie, a woman, beat him to it. And he couldn't handle that. So he argued as hard as he could against both Edmund and Nettie's interpretations. Why was he doing this? Because he was doing his own chromosome thing with fruit flies and wanted to be the only one who discovered this. Buddy boy, that's not how science works. That's not how that's just not how life works. You are not the first to discover walking. The baby, you think that you're the first one to discover walking, but I guarantee you, somebody else discovered walking. He pushed Nettie out of the way so hard, plus women just weren't given the recognition they deserved, that in 1906, he and Edmund were both invited to speak at a conference to present their theories on sex determination, while Nettie was not invited, much less invited to speak. Then, Thomas shoved Edmund and Nettie so hard out of the way that in 1933, this stealing jerk won a Nobel Prize, quote, for his discoveries concerning the role played by the chromosome in heredity. It didn't even mention Edmund, much less Nettie. He didn't only not mention Nettie's first main only contributions to sex determination and chromosomes, he basically stole it and just slapped his name on it. After her discovery, Nettie continued to do research and teaching at Bryn, Mawr. She may not have had an official university position, but she made a career for herself by doing research at leading marine stations and laboratories like the Cold Spring Harbor Laboratories in New York. The highest position she reached at Bryn Mawr was an associate in experimental morphology. She published about 40 papers on many topics. She did more papers on chromosomes, but also in regeneration and taxonomy. I think that's how you say it. The classifying and naming of living things. In 1910, Nettie earned a star next to her entry in the American Men of Science. When that happened, she became ranked among the top 1,000 scientists in the entire country. She was one of only 18 women on that list. Boom. Nettie Maria Stevens died on May 9th, 1912 in Baltimore, Maryland of breast cancer at the age of 50. She died only 9 years after receiving her PhD. She never married nor had children. She is buried at Westford, Massachusetts Cemetery next to her father and sister. Her life was short, but her career was even more criminally short. It may have been short, but the strides she made were more than her male companions and helped the science of chromosomes and genetics make massive strides. Thanks to her discoveries about sex determination, we have the basis of many achievements in the research of Down syndrome and Turner syndrome, a genetic condition that affects females where one of the X chromosomes is altered or missing, which leads to many developmental and physical differences. In 1994, Nettie was, as she should be, inducted into the National Women's Hall of Fame. On July 7th, 2016, Google made a doodle of her in celebration of her 155th birthday and her discovery of chromosomes, because that's what she just did. And on May 5th, 2017, Westfield State University honored Nettie through a naming ceremony of the Dr. Nettie Maria Stevens Science and Innovation Center. Here, the university's STEM-related degree programs in biology, nursing, and allied health, chemical, physical, and environmental sciences are held. They recently launched a master's program in physician assistant studies in the same building. Without Nettie's insane discoveries, who knows how long it would have taken to learn how chromosomes, sex determination, and genetics even work. Nettie became successful in a world that assumed women were inferior and opportunities and recognition was non-existent, and though this jerk freaking Thomas tried his best to erase Nettie and take credit for her discovery, it worked for a bit, but the history books never forget. There you go. The immensely interesting, fascinating, a little bit complicated on the sciencey part story of who discovered chromosomes. A woman discovered chromosomes. I had no flippin' idea about that. Just goes to show my channel is needed more than ever in a time where women are being actively erased from history. Now you know, woman discovered chromosomes. Not a man, not this guy, and especially not that guy. That guy can go jump off a microwave for all I care. If you learned something today, and I sure hope you did, please like, share, and subscribe to this channel. And while you're down there, please leave a friendly comment. I'm sorry for my voice. I'll be better next week. And next week, I got a doozy of a girl coming for y'all. So I will see you in my next video. But until then, don't be well behaved. You just might make history. See you next time, gals and guys.